Profiling your application can be very useful in order to improve the performance and the user experience. And I'm going to use this drawing application. I already started making this app in a previous tutorial, so you can look at how I made this. Or if you just want to directly use it, you can find the link to the GitHub in the description box. So it's a small little app where I can simply draw on the canvas, and it's saving these drawings. So the next time I'm launching this application, it does bring me back to the same drawing. And I also save the color and the line width here, selected for the sliders and user default. But I have started noticing, especially on device, that things get a little bit, as long as I only have a couple of lines, everything is fine. But my application starts to stutter as soon as I have a lot of drawings. And in order to see this, I had to here make this little video of myself drawing on my iPad. So you see I just scribbled all over the place. So I can show you the part where you see the line. So what happens is that it starts to lag. So the line is not very responsive anymore. Like here in the beginning, you see the line is really directly appearing as soon as I start to draw, because obviously that's the way it's supposed to be. You want to have directly the line appearing for each of these touches with the pencil. But if I have a lot of drawing, it's getting slower and slower, and there's a bigger and bigger lag. And this is just the extreme here of only at the end, when I actually finish this line, it starts to appear. So this is really, really bad user experience, and I need to find out what I did wrong. One thing I can use is in Xcode, the debug navigator here on the left. So we can have a look at the CPU usage. So every time I draw here, you see it's going up. And this is quite a lot. And need to scribble here a little bit more just to get it over. The thing is, it's using the resources of my Mac, so it's not very representable of a real device. Usually this kind of performance issues is better to just on an older device, because they are not having the maximum power. So I'm managing here now to get to 85%. So, and here you see this increase. This is actually the graph that is more interesting, that over time, the more I draw, the more I'm using here. So something is building up, which seems to have to do with the amount of drawings I have. Can also have a look at the memory. It seems to be still very low. And then you can use at the disk. So you see here have the blue one is reads and the red one is writes. So I seem to have a lot of writes, way more than I should. And every time I'm drawing, I have quite a couple of these writes. Might seem to have some problem with the writes too. So maybe there's a combination of saving, writing to disk, and my performance issues. So this is the first indication that something is wrong. In order to really see this, we're starting now using instruments. You can go under Product Profile, or the shortcut Command I. And before I actually do this, I'm going to choose not the simulator, but the real device. So I'm switching to my own device. This is simply because in the simulator, it would again use the CPU of your Mac and storage of your Mac. So it might be misleading in what the system can handle on your Mac and what a smaller iPhone would be able to handle. So this is now instruments, where you can look at different tools, templates. I already have here Time Profiler selected because this is the one that you might use the most. We are also having a look at SwiftUI in a little bit, just to see the performance. There is also a dedicated one for CPU Profiler. And I have here also time lane. This is separately, it does not come with instruments. This is for combine. So let's start using here Time Profiler. So we have here my iPhone selected with the app that I wrote selected. You can also switch and profile a different application from here on. So let's just record, and I'm pressing here the record button. So it's launching now the application on my iPad. And you see it's already start to pick up some data. So I'm drawing here something. I have already quite a lot of drawing on my iPad. So now I stop. I just had here, as you see, 4 lines. This is the heavy traces. But you can see because I'm using here 100%. When I was just drawing, I saw this lagging effect here, again between the line. So maybe I try again from scratch. So we see, so I'm deleting first my document. And now I start writing again. Okay, now I have here 4 lines. This should be enough to start looking into this. I can pinch to zoom in to the graph. So up here, this is the time profiler. I did use before points of interest, which you can also use to really see specific events happening or tracking things being done. Down here is my drawing app. If I unfold this, you can see all the threads. So we see on which thread is done which something. And the last one is the main thread, and it seems that I do a lot of stuff on my main thread, which is really not good. And we need to, in order to have this lagging effect going away, we need to definitely take off as much work off the main thread as we can. Unless, of course, it's really important. So you can, up here, on the timing frame, if you scroll there, you see some indicators showing more details. So, or we can select a specific area, just click and drag. And it does give you the traces in a certain interval that it was keeping measuring. Down here you can see the traces, and by unfolding this, which might take a little bit longer. On the right, this is actually the most interesting, or one of the more useful things, is the heaviest stack trace. So I can have a look at what is the main work done by this application, what is taking the most work. So I have here my drawing app main, that's what I'm expecting. It's my app, and I'm scrolling down. I have here, if I click on this, you see it's opening this stack trace, and I'm here having my drawing views body getter. You can also double click on this, and it's bringing you to the code. It's showing you the code example in your file that is called. So you see here it's 100% telling me it has to do this vstack recreation. I'm clicking here close to go back. Then let's have a look at what is actually, it's like going downwards. You can see what's called after which other. So we have here the body getter, the hstack initializer, and the body getter. So now let's have a look at the different area. So again, I have here my main, and here you see I have my body getter, lines modify, lines did set, and document save. If I double click, you see here I'm going to the save call, and it's again telling me that it has doing a lot of work for this. The other thing is, if you look at the work that is done, that most of it is actually on the main thread, because I'm not actually putting this work on a background thread. So let's improve this by going to our Xcode project. You see here there is a small Xcode button. I double click, and it brings me to the file in Xcode. So I don't even need to look for it, which is very nice. So I'm here encoding and writing it to disk. Definitely this should not be on the main thread. This does not have a high priority. I might do this if I'm not actively updating my UI. So I'm using here dispatch q.global, so I can use one of them. And this definitely doesn't have a high user priority, so I'm not going to use user interactive or user initiated. I'm going for background. So I'm here using async to wrap everything, and I probably have to use here unowned self, because I'm using here my self's lines and my self's URL. So at least we should get this work of the main thread. So I can test this again with Command I to build this in instruments. I'm going to start this again. Sometimes it does take some time to build up. So I'm drawing here maybe 3 lines. So what you see it still has the encoding as lines in there. And I'm unfolding this, but we have now quite a... If I click now here on this thread that has really a high percentage of work, I see the stack trace on this one, and it's actually the save action that is put on there. So here my main queue has a reduced, so my main queue is more free and doesn't do this work. You can also see that because I put it as on a background queue, it's automatically managing, the Grand Central Dispatch is managing on which queues, on which background threads it puts this work. So we see this saving action put on multiple of them, like on this one. So now the question is, I need to test this again to see if my if it's still doing this lagging if I have a larger document. So, or actually scribbling like a maniac. So this is the recording I just did when my canvas was pretty busy. I mean, I had a lot of drawings on it, and this is actually 2 different lines, but it looks very, very busy. We're definitely doing something too much. And let's have a look at the drawing app. So my background threads here are extremely busy, but the main thread has 2 distinct areas. This is when I did these 2 lines, where it's actually doing the drawing. Still doing too much drawing, but maybe we can fix here this background threads, because I'm saving too much, too often, because I'm calling here this save functions too many times. And actually it's even the encoding part. So we need to reduce the number of times we do this. Right now I did use here, the reason why it's actually so overwhelmed is because I'm saving it here every time one of my lines changes, which happens every time I'm adding one of these points. So for multiple times during this drawing cycles, I'm updating this. So what I want to do is I want to maybe every couple of seconds only do the save action, not every time the whole line is. You could also save it every time you finish a line, but this means I would need to change the way I'm storing my lines right now. I don't really want to enforce that on my process. Just want to here have a simple way of every 2 seconds save it. The rest I really don't care about. So we need to have a way of easily know when 2 seconds are up to save it again. And with functional programming, this is much harder with the save implementation. So this is very easy with Combine. So I'm going to show you a quick fix for this. So at first I have to import Combine, then we need to here create a data stream. And in this I have to store my subscriptions somewhere. This is a set of any cancellables. So in my initializer I start to create this data stream, which is working very similar to this did set. So I'm just going to comment this out. So if you want to, instead of a did set, you can use a $lines and then use the sync. So here I also would get my newest lines. And then here we could call the save function. Need to store this in my subscriptions. So this is exactly the same behavior as with this did set. Self dot, which means that I have to here use unown self. But I said I didn't want to actually save it so many times. So I want to limit here what is passed down. And for example, you can use filters. Maybe in the beginning your line is actually empty. Then I don't want to save this, so it shouldn't be empty, otherwise don't let it pass. We can also use here in order to have this every couple of seconds. So there's 2 ways of, in a time interval, restrict what values are passed. One of them is throttle and one is debounce. I'm just going to write both implementations. .main. So here you can specify in this time interval, do I want to have the value arriving the latest? So this is the newest one, which I definitely want. So this is true. When we have here debounce, so also for 2 seconds, run loop .main. So the difference between throttle and debounce is that this is fixed per interval. So that's always, if there's a value coming in this time interval of 1 second, 2 seconds, then this is going to be published, and I'm publishing here the latest one. And debounce means it's for bursty events, which means that there needs to be no value coming for the last 2 seconds for 2 seconds in order to publish one value. We can also see this in the time trace. So let's start with throttle, because this is going to periodically publish one value every 2 seconds now. So you see here one line to have here multiple lines, and there's some spikes. Just going to have a look where they are. So I'm going to select this thread, and down here in the heavy traces, it's the save action. And because I put it on a background, I put it on the background queue, it's going to decide which thread, the Grand Central Dispatch is going to choose which of the threads it's actually running on. So that's why you see the save action going for different threads, but they're still 2 seconds apart. So if I hover over here, you see it's somewhere 5 seconds. If I hover over here, it's 7, 9, 11, 13. So every 2 seconds it's indeed saving something, because I did draw in between. So now let's try the debounce to see if maybe for this kind of bursty event this is better. Okay, I do have here a couple of lines which I did try to draw at different timings. So I see here there is this thread has some heavy work done here, which is indeed for my saving. Then I have one here. So this was at 3 seconds, and the next saving is at 9, so definitely longer than 2 seconds. But the reason is there's a difference of 8. So here I'm around 7.8 seconds when the last event happens, and here I'm at 9.8 when the save action actually happens. So you see there is nothing done in between, and only then I'm saving. So I have a time distance between my actual, what happens, my drawing action, and when I save it. Then I start here drawing again at 11 seconds, which means that my saving would happen again at 13, and it happens there. So this is quite useful if you want to improve your actions. And this is actually a nice little data stream. You didn't have to do a lot of difference to before, because I'm still using here my save call. We could also do all of this in the data stream by using here an encoding operator and the try map operator to write this. But this is up to you if you want to. You can combine this to functional and combine data streams if you just want to use it here for this filtering. Now this is actually one of the examples I really like about Combine. This is one of the use cases that's really good about Combine to have some performance optimizations. So now that we have, it seems we did take out a lot of work. Our UI got a lot more responsive. I can even draw for longer, larger documents. But if I have a really big document, you see here I'm already building out quite a bit of work on doing drawing. And this is my main queue where I actually do the drawing. So in this case, you see here I have the path CG getter. If I click on my time profiler again to see what actually happens here during the time I only draw, I have some drawing action, and I would like to investigate more what it actually does. And for this I'm going to use a different instrument. So you can add more instruments, more templates here by pressing on this plus button. So if I scroll down, I have here the time profiler that is just already used, so you could add this also, and there is some that are included with SwiftUI. This is this view body and view properties. Just going to add both of them. So they have no data yet because I didn't add them when I was recording last time, so I have to start again. So I'm just going to do 2 drawings and stop again. So if I click on this body, so I actually have to use here something where I actually draw. So this is one of these blocks. And then down here, I see all of this is the body properties, something that in your views that is recreated, what is actually recreated, how often is recreated in this time interval that I selected here. So you have here the timing summary and the intervals. The timing summary. So I have here some SwiftUI related code. So it seems to have recreated nearly 600 times buttons. Then more interesting is what I have specifically for my views. So this is this drawing view, which is recreated 65 times in this period. Then let's have a look at the view properties, because this is giving you the properties that are actually causing this redraw. And I use here again summary. So this is the, you see here now the state properties that cause the redraw of our body. And I can now check actually if what was updated. So my scene face was always active, this was not yet. The line array not. So one thing is I don't see what line it is, but it's probably my deleted lines, because the other lines are in my drawing document, which is the last one. So I didn't seem to have updated this ones. This was always false. My user color was always the same. So if you here press on this arrow, you can have a look at what this actually looks like. It's probably not the best example for this. And then here the user document. And in this case, this is the one that is updated the whole time, obviously, because I added here always a line. So what happens is that for each time I'm changing for each time I'm adding a line, I'm changing my drawing documents data inside, which fires the object will change, which causes the body property to redraw. And you see this here, it's 65 times updating this property, which causes 65 times the redraw of my view property. So what is mainly on the done in the UI is here redrawing, recreating this. I need to update my drawing view every time this changes to show the newest lines. The problem is it actually draws all of the lines for this. Every time one line is added, it redraws the whole image. We could also try at this moment to check if the canvas is better performing or not. So I change it now to the canvas. I delete the document and I redraw again. So here I can inspect. If I now go onto my view body, select one of these areas where I did draw, and then down here in the timing summary, I have a look at the drawing view. I see that the average duration to redraw, to recreate this, is 150 microseconds. I do this 57 times. The thing is, the screen has a refresh rate, depending if it's a newer one. It's either 16 milliseconds or 8 milliseconds. So we are still quite below this. In this order, it would be 8,000 microseconds refresh rate that we would need to not see this lag. So it's good enough in terms of not seeing the effect of our heavy calculations. It's still not good because I do here more work that I actually want to. But you can see how long which views take to recreate. Right now I only have here one view, but if you have multiple, you would see how long which one takes, which might cause you problems. So this is the one that I had when there was really just one line to draw. And this is the one that I had before I deleted it. So it still takes 140 microseconds. It can still perform enough. The only thing is just I'm putting here quite a lot of strain on my iPad, and I might not want to actually do all of this work because every time I'm here drawing something, it's redrawing everything. If you do this in UIKit, you could just draw a little bit. When your user touches, I have, for example, here my last point and here my newest point, and I would only redraw this area for each of these points. Then I move to the next point. I would then redraw this area to add this line in between. In UIKit, you can really fine-tune, say which of these areas I want to redraw. Whereas in SwiftUI, it's going to redraw the whole thing. It's going to recalculate this whole paths again. If you have some performance issues, don't calculate anything in the body property that you don't have to. So because this is actually this part, this whole body part here is recreated every time I'm changing one of my lines, which is why I have such a high strain on my iPad. So I could try to move these paths outside, so at least I don't need to calculate them again, but it's still a matter of, it's just a workaround that this kind of work I'm just not willing to put into, because I'm missing the kind of control I have with UIKit. This was supposed to be an example of, I just wanted to know how much I can push SwiftUI for this specific use case for drawing app. So I'm guessing it's probably not the best use case for SwiftUI for this performance issue here. If you have a more static UI where you just show a list of images, a shopping app, you probably don't run into these issues. But it's just me who wants to have the best performance with my drawing app. So this is another reason why I would probably drop back to UIKit, together with the fact that I don't have as much control of my gestures here. Because I want to have information of when I'm actually here using a pencil, maybe the force. I don't have the possibility to implement palm rejection, because I don't know if it's a pencil or my hands. So that's a bummer. But just for a simple, small drawing, not like a huge document, using the SwiftUI is fairly enough. It's a lot faster to implement, and it's very simple to do. Also in conjunction with all these UI controls. So I'm leaving it with this decent enough performance. I hope I could motivate you a little bit more to use instruments, and it wasn't too confusing and understandable. Unfortunately, there's not a lot of resources for instruments for profiling SwiftUI to know when things happen. So I was just trying to find out by myself how I could use it, what could cause these problems. There's probably more potential in this than what I showed. Go ahead and also use instruments for your projects and tell me if you could actually find some interesting insights and improvements with this. Give this video a like. See you next time. Happy coding.